As anyone who ever visited us in our old house knows, the water quality from our well was substandard. It was one of the biggest decisions we needed to make early on about whether to build a new house, was how do we rectify and improve the water quality. We looked at treating the existing water. It was expensive and not all that effective. And we finally settled on capturing rainwater. Our neighbors do it, and the climate should support it. But how do you know it will work? Well, the answer lies in what they call a water balance. You need to understand the rainfall statistics for your climate monthly. You need to understand how big of a storage system do you need to have in order to never run out of water. And in the Comox climate, it's a bit tricky because there's lots of water in the winter, but there's very little rainfall in the summer. So you need a big storage volume to last the dry summer. If you have a big storage volume, you need to make sure that you build enough roof area that you can capture enough rain to actually fill the tank so that it's full when the dry weather starts and you can survive the dry months without running out of water. So all of that is called a water balance. So when you've got your statistics and you've made some assumptions about how much water you're going to consume, and you know how many people will live in the house, and you know how big your house will be and how much roof it will have, and you know how big of a cistern storage volume you're able to build, you're able to do the math. And what this graph shows is essentially month by month over a 3-year period, the fact that we should have no problem running the entire house with 2 people in the house and never even getting sort of below 2/3 of a full tank of water. So that's comforting. Now, of course, you wonder when you're doing all this math whether you're doing it properly or not, and so it's very thankful that our neighbors have a similar system and theirs works well and they never run out of water. So the next thing is actually designing the system, looking at your roof, deciding where all the downspouts should go, and on your site, how are you going to capture the water and where and how are you going to move it to your cistern. Now, ideally, you put your cistern at the lowest point on your property and all the rain falls from the sky, off your roof, through your gutters, down the downspouts and into the tank. No problem. I put this photo in to just highlight one of the predicaments we had was our site slopes towards the water, of course, but there's really not very much room behind the house to put a big cistern. And it's on the slope and it's potentially unstable, and we don't want to put a big massive weight of a bunch of water on the slope. So our tank ends up being in front of the house uphill from where the water wants to flow. So in our system, the rain will flow off the roof into a small buried tank behind the house, and we will pump the water up the hill back to the front of the house and into the cistern. So these next few photos just illustrate that round green tank which goes behind the house. We call it the transfer tank. All the water that comes off the roof goes into that little tank, and ultimately when it fills up, the pump turns on. There's a pump in the bottom of the tank and it pumps the water up to the front of the house, up the hill about 10 feet higher to the cistern. So from here, let's just follow a drop of water. How do you design an entire system to capture rainwater? The first thing is a metal roof is great, and a steep metal roof is really good. They trap less contaminants, they shed the water efficiently. Now from the roof, it goes into the gutters, and from the gutters it goes into the downspouts, but they're not all created equal. We chose to put in some what people would call premium gutters. They're half round, they're not an angular shape like most gutters we typically see are. Half round is very efficient. The water concentrates in the bottom part of the circle and it flows efficiently, moving debris efficiently, and as such I thought that would be a good choice for the gutter system. Another rule of rainwater harvesting is only put clean water in your cistern. So these little screens at the bottom of the downspouts are the first line of defense to keeping the water clean. You see they are quite a big grate, and you have to sort of continually monitor them and scoop out the leaves and pine cones that are going to accumulate in those little hoppers. But that is the first very coarse level of filtration that we have on the water. Now from this point in the system, the water goes underground. So here I'm showing the white PVC underground collection system that routes the water from the downspouts into the downspouts. All go into the vertical pieces that you see on that sloping line. It all runs around, all the downspouts aggregate into one line, which effectively and ultimately goes into this green line, which goes into this high-tech German vortex filter, which is really the primary cleaning mechanism that we have on our water to make sure that the water that goes into our storage system is clean. Now this thing is pretty neat. It's a vortex filter. What you see there is the top horizontal line is the inlet. You can see it enters on the side and the water comes in and swirls around. There's a metal strainer basket inside, which filters the leaves and the pine cones out. The debris goes out the bottom, and the clean water goes out the white line in this picture and into the transfer tank. It's really quite clever. You'll see the water here in a moment. It starts to swirl around. When the screen gets wet, the water starts to flow through the screen, and you only see a small percentage of the water, which would have the debris in it, is dripping down the bottom, which is actually the waste flow. The clean water is going through the screen, and you can't see where it's going in this view. Here you get a bit of an idea what the thing looks like, and the screen up in the top right. And really what I would draw your attention to is the chart in the bottom left, which basically says these things are incredibly efficient. You have to have a massive flow rate of water before this thing doesn't perform. 95% of the water should get captured, and only 5% of the water should go out the bottom with the debris. Here you see that clean water flowing into the green transfer tank. There's another look at what that tank looks like. I know the water doesn't look clean. That's an old photo from early on when we had filled the tank with grungy groundwater, just so we had water on site for construction purposes. So here's another interesting thing that you need to think of. So remember I said there's a pump in the transfer tank. This is what the pump looks like, more or less. And there's a level switch, a float in the tank as well, that when the tank fills up, the float floats to the top, it flips a switch and it turns the pump on. As the pump empties the tank, the water level drops and the float drops down to the bottom. When the float gets near the bottom, it switches again and turns the pump off again. So you need to size that pump properly. You need to know how fast is this tank going to fill up if it's raining really hard, and you have to have a pump that's powerful enough to empty it faster than it's raining, and you also want a pump powerful enough to empty the tank relatively quickly so that it's not running for hours and hours every day. It's kind of an interesting experiment, and the chart the charts on this picture just show that even in a heavy rain in this climate with, say, 3 inches of rain in one day, this pump is 10 times, will move a volume of water 10 times bigger than even a massive rainstorm. So the pump will always be able to keep up with a heavy rain, and it's sized so that if it's not raining and the pump turns on, it should only take about 10 minutes to empty the tank. So returning to the cistern, the ultimate destination for the storage of all of this beautiful rainwater that we're going to use in the house. Here you see photos from early on in the construction, cistern in the distance in this photo. Here you see the walls of the cistern, essentially the basement under the garage being formed. There you see the walls with the form stripped off and the fresh concrete. And here you see the clever system which we used to support the floor of the garage, the ceiling of the cistern. It's these clever metal pans. They bridge across the span of the garage, the width of the garage. They have these deep channels in between the sheets, the pans, and those form almost floor joists in the concrete. There you see the concrete as it's poured. The rectangle in the left-hand side is going to be the access hatch, which will allow us to get down into the cistern if we need to. Now here you see the guys pouring the concrete. I put this little video in because it was a bit of an interesting day. It's a great day, and the guys were a little nervous walking on these pans. They asked Drew, well, is that going to support our weight? He kind of chuckled and said, well, it's going to support a car. I think it will support you. There you see the access hatch. And here you see inside the cistern, the liner which we are installing inside. You don't need the liner necessarily, but it keeps you from worrying about cracks in the concrete and water leaking out of your cistern. And also concrete is quite alkaline, so it can affect the taste of your water. Here we have Woody plugging in the transfer pump for the first time and us hoping like hell this is all going to work. Again, don't panic at the little bit of dirt. That's just debris that was obviously in the buried lines between the transfer tank and the cistern, and that will be diluted with 12,000 gallons of fresh, clean water. And all that sediment will settle to the bottom and never get sucked into the house anyway, which I'll explain a little bit later on in the video. What you see there is called a calming inlet. The way you want to pump the water into the cistern is you want it to go down near the bottom, and you want to reverse the flow so that it's actually U-tubes and comes up near the bottom. It keeps from disturbing sediment on the bottom of the tank, and it keeps you from disturbing anything floating on the top of the tank. You don't want to just spray it into the top of the tank. It disturbs the water and makes it less clean. Here you see two lines coming into the cistern. The one on the left, the small one, is the inlet to the cistern from the transfer pump, and the bigger one is just an overflow line. So if it's full and it continues to rain and the pump continues to pump water into the cistern, it will just naturally overflow, run to the back of the house to our manhole cover and down the slope towards the beach. So the last little bit of the cistern that we haven't spoken about yet is the suction line into the house. So this is the feed line into the house. It's not a great photo, but as you can see, it leaves the cistern down low near the floor. The blue on the right is actually a flexible hose, and there's a screen and a float on the other end of that hose, so that the suction line is always pulling the water from just below the surface of the cistern where the cleanest, most aerated water is. So from a water quality perspective, apparently that is the correct place to take your water inlet into the house, is from just below the surface. So as this level in the cistern goes up and down, the float will take the suction line up and down, always feeding the house from the right level in the water column in the cistern. You see what I'm trying to say in the left-hand side of this little diagram. That gray box on the left represents the cistern, and you see the floating suction with the ball that rises up and down with the water level. Now the other part that we haven't talked about at all yet, if you follow a drop of water, is where does it go when it leaves the cistern? What happens inside the house? So this little diagram is just intended to complete the picture. If you focus on the rectangle in the bottom right where it's labeled basement mechanical room, I'll just quickly let you know what is planned in the house. So you have to have a pump to provide pressure to the house. The water was going to flow out of the cistern, through the basement wall, and into a jet pump. The pump's going to pressure up the pressure tank, which is the big oval that you see there, which sort of stores some pressure and keeps the pump from having to run all the time. It's like a big balloon, basically. And then the water will go through two filters. It'll go through a 5-micron sediment filter, and it will go through an activated carbon filter. This will remove any particulates, that are in the cistern water, and the carbon filter will help with taste and odor, which I don't expect any, but that should be good protection. And then after it's filtered, it runs through a UV light, which basically sterilizes it and makes it potable water. We're going to run it through a water meter so that we can measure how much we're using, and that will help me understand whether all the math that I did at the beginning was correct or not. So at the end of all of this, we know from the little video a few minutes ago that we actually have water in the cistern. Will it be any good? Well, here you see two samples. One is from Comox, tap water from Comox, and the other is rainwater straight from our transfer tank, so not even filtered in the house. I'm pretty pleased to say that I can't even remember which is which. They look the same. All for now. Bye.